Species endemic to islands show extensive variation in comparison to non-isolated environments. However, there is little variability in taxa. Using Hawaii as an example, we can explain the evolutionary concepts that contribute to island speciation. The main factors driving this island speciation are the founder effect, adaptive radiation, and the variability of island environments themselves.
At the basis of these concepts is the formation of the islands themselves, which is essential in establishing how island speciation occurs. The Hawaiian archipelago was formed from seafloor spreading over a hot spot. Because these islands are spontaneously emerging from the ocean, the life existing on islands today must have traveled there as they were not present at its formation.
The founder effect occurs when a small population establishes a new population with little to no gene flow from the original population. This new population becomes allopatrically isolated from its original group, reducing gene heterozygosity, which is a measure of population diversity.
After a new species arrives on the islands, and as the population increases, selective pressures will begin to take over. Because there are limited resources on islands, intraspecific competition, which is competition between members of the same species, drives disruptive selection.
Once a species has established a population on the new island from the founder effect, adaptive radiation begins to occur. Adaptive radiation is when many branches of species, which are often variations of each other, diverge from a single ancestor. The honeycreeper is an example of this phenomenon occurring in Hawaii. These birds are very similar to one another morphologically, but their beaks are highly specialized and reflect ecological characteristics and behaviors.
We can use this graph to illustrate how adaptive radiation and disruptive selection drives island speciation. At the morphological average, the competition between members of the same species will be most extreme because they will use the same methods of obtaining limited resources on the island. As a result, the extreme ends of morphology will be favored because they have less intraspecific competition and will therefore have a better chance of survival.
Another aspect that occurs in island speciation is the island effect. This effect has two major facets. The first is that larger animals generally become smaller, and the second is that smaller animals generally grow in size. As mentioned before, island resources are limited. Because of this, larger animals will reduce in body size to limit the energy premium required to sustain homeostasis and existence. The dwarf elephant is a quintessential example of this effect. These elephants, which evolved in the Mediterranean islands, are about one-third the size of their non-island counterparts.
In contrast, smaller animals will increase in size to become more competitive. This aspect of the island effect can be seen in an extinct species of duck, endemic to Hawaii. This duck was a much larger, flightless version of its non-island counterparts. In fact, its body size increased to the point of becoming flightless.
Ecological diversity can also help drive speciation. This is especially the case in Hawaii, as its geography ranges from tropical warm shores to snow-capped mountains. In fact, Hawaii is home to some of the hottest and coldest places on the earth, as well as some of the wettest and driest. This variance in Hawaiian ecology facilitates different modes of adaptation. It allows for multiple peaks on adapted landscape to exist, giving rise to a multitude of viable evolutionary paths. Adaptive radiation and the diversity of Hawaii's environment work in conjunction to promote island speciation.